Okay, good morning. I'm Yang, and I'm working for P&G with Michael Thompson sitting over there, my colleague, and in corporate function data and modeling science. We mainly use BayesiaLab for product research and understanding consumers' motivations. Lionel has goes through the features. I try to elaborate a little bit on what is the business context, what motivating us to develop this method and request these features from BayesiaLab to do this. So here is the common scenario. When you build a BB network and generate the total effect or standardize the total effect, we call that is drivers. If you work out the mathematics, you will know why that is drivers. Literally, that's like in the analogy of linear regression, it's like the slope of your y versus x. So the higher the coefficient, the higher your response will be. And after we, usually the driver analysis is for the whole category. Let's say shampoo. For the whole shampoo category, you try to know what motivate, what drive consumers to purchase. Is that because of cleaning? Is that because of shiny of your hair? We try to understand that. But after that, after we know the drivers in this category, the natural question from the management, you usually will be, hey, why don't you look at our product, our single product, let's say Pantene, what product benefits or what product attributes impact our sales? We cannot say drive, because drivers is for people, it's for consumers. As long as consumers are given whatever product you give to them, the set of conditions motivating them to buy your product or drive them to buy your product will not change. So we developed the method to try to, to address the problem is like, if you want to look at a single product leg or single consumer segment, what should you do? So here I wanted to present three pieces. The first is why you should not build a single product model or small base size model if you want to look at a single product leg. The second thing is how you use impact analysis, landscape analysis, and profile analysis in and BayesiaLab 8 to sharpen your understanding to understand a single product leg. And then if I get time, I can do I have a generic case study to do the demo. So in, let's say, analogy in the regression space, if you have multiple product legs in the category, and each of the product leg you collect sufficient data points, the overall model, the underlying model is a purple line. You are fine. But if you want to say, okay, what should I do if I wanted to understand product one? People will, most of people actually will do just build a model on product one, stratify the data, and then build the model on product one. In this analogy, if you build on product one, you will still have a trend, like trend is correct. And you do product two is also fine, but if you are unlucky build on product three, you have a quite opposite trend. So in the best scenario, you have a biased model. In the worst scenario, you will have a misleading model. And let's say another scenario is you have multiple product legs, but each of the product leg you only collect few data points to, let's say, reduce the cost. You build a model. The underlying model again is overall the gray line. But in this scenario, even you have multiple product legs, under the limitation of a small base size, you will have a correct model. That again is a biased model. So what should you do? What should you do if you want to analyze a single product leg? The simple idea is you borrow information from other product legs. I will elaborate a little bit on that later. Like in analogy of regression, you borrow the overall slope from the category model. Or you don't have a category model at all. You have some category knowledge. You know the order of the importance. You can also do something with that. And we developed 3 methods we mentioned earlier in PNG, and we even built an internal web tool to satisfy the demands from our practitioner in PNG. But thanks to Lino and Dennis, they make it really quick, and this year we're going to have these 3 features enabled by BayesiaLab Ed. So landscape analysis, something wrong? Okay. So landscape analysis, we try to say in one plot, we try to say what are the drivers in this category. And then on this driver, what are the positions of each brand versus each other, and also marketing average. If you have sufficient, base size and product legs, it will give you the landscape in this category. And then impact analysis will single out one product leg and compare it with overall category. That's by default in BayesiaLab right now. You can also compare that with a benchmark product, could be a competitor product or your existing product, to see which part you are winning, which part you are losing in terms of product benefits. And then profile analysis is the tool. You can, let's say you have multiple benefits. One product provides multiple benefits. How do you compare 2 products? Just, you can do bar chart, but we think radar plot is really a nice visualization to do that. And also, as Lino talked earlier, you can test the significance using frequentist way to see whether it is mathematically significant, or in Bayesian where we said, according to the drop size, the region of practical equivalence, you can tell whether it is practically meaningful or not. And here, Lino already elaborated talk about the equation. So here's the idea. The total effect, the green part, is the information borrowed from the category model, from the overall category model. You should really build a model, using the overall category data. Or if you don't have the data, you use category knowledge, at least you know the rank of each of the benefits. You use this to weight the red part. These are the factor scores of your individual product leg A versus average of your benchmark. It is a B. It could be category average. It could be a competitor product. And if this is a quantitative number, meaning if it is a real quantitative number derived from a real model, mathematically this roughly equal to changes in your target. So we define this as impact. What is the impact of benefit I on product A versus the overall category? The start point is really a BayesiaLab. You have to really build a network, validate the network, make sure the network represents the category knowledge. Each of the benefits is fine. In this case, it's a generic case. Let's say in this category, different product will have different benefits. They drive OAR and purchase intent. OAR is overall rating, by the way. So you do this from analysis, segment. These are the 3 methods. So the plot you're going to generate, as Lino showed, I'm sorry, the font is a little bit, small. I didn't figure out a way how to change the font on the plot. If you blame Dennis, maybe. So this is your driver, represented by standardized total effect. So it shows the vertical part is the driver. It tells you what are the drivers in this category. And furthermore, tell you, let's say on benefit 2, this is the second driver in this category. It will tell you the individual dot represent each brand, the average of the brand benefits on this driver. And this one also gives you, I think, overall is the average in this category. You will see what is the position of your product versus all other product, and versus the category average, or versus your competitor. You can do it that way. And here is the impact plot. In this generic case, we try to say, okay, green meaning you are winning versus the benchmark. In this case, the overall category average, meaning you are better, you perform better versus the category average. And essentially, this plot will tell you what product benefits differentiate your product from the benchmark product. In this case, the category average. And green meaning you're winning, and red meaning you are losing. And furthermore, if you do the test, you can tell whether the gap, the difference, the change in your target is significant or not, or practically meaningful or not in Bayesian way. I mean, you can tell Bayesian is more conservative. This is the dark blue. I'm not sure it shows correctly. It's more conservative. That's because mathematically, as Leno showed earlier, the frequency test is simply test whether the difference is equal to 0 or not. So the Bayesian test, you try to say whether the sampling, the posterior sampling, the difference of the sampling is outside of region of equivalence interval or not. So that's why we think, Bayesian way is a better way. Not better way, it's a conservative way. If you find one difference is Bayesianly significant, we're going to say that's indeed practically meaningful. I mean, you can refer to this paper if you want to know the detail. And here is, some other product in this generic case. Apparently, we see product 2 is the winning product, is the winner in this category. It is winning virtually on all the product benefit space, and product 1 is the loser product in this category. It's losing in virtually every benefit rather than on benefit 3. I can tell you benefit 3 is, let's say, value for money, meaning it is cheaper. Consumer gonna say, okay, this is good for this is cheaper. This is good value or something. And these two products, let's say, you notice benefit 1 is the winning is the winning part for product 5, but product 3 it is a negative impactor. That's the way you can use this quite intuitively to communicate the ideas to the management and say, hey, for this given product legs, which part we are winning, which part we are losing, what should we do, whether the difference is practically meaningful or not. So here is the profile analysis. If you want to say, okay, I have multiple dimensions, try to compare 2 product legs, what should we do? So you can simply profile them. Each of the vertices is a benefit or key measures like overall rating. You can profile all the product like this way, and then you can pick any 2 single one product versus another in another plot. Is simply the further away from the center, the better the product perform on that benefit. And of course, you can also test the significance using frequentist way or Bayesian way, using the same method from Krusky's paper. In this case, you can tell the blue line, the product 2 is winning virtually on all product benefits, other than product benefits 3, and it also tells you whether the difference, the gap, is meaningful or not. So yeah, the summary is single product model or small base size model are often biased or misleading if you build a BB model purely on that single product or small base size. And a single product model with larger base size may not provide meaningful signal. You are chasing noise essentially in consumers' response. And we think landscape plot, impact plot, profile plot enabled by the new release of BayesiaLab at will help us a lot to do product research analysis.